Bitcoin Technology Fundamentals. I am Amitesh Raikwar, I am PhD scholar. In this tutorials series we will learn Bitcoin technology fundamentals.
In this video, we will discuss about Bitcoin networks. First of all, to understand Bitcoin network, we need to have good knowledge of networking. Bitcoin network is a peer-to-peer payment network that operates on a cryptographic protocol. Users send and receive bitcoins, the units of currency, by broadcasting digitally signed messages to the network using Bitcoin cryptocurrency wallet software. Transactions are recorded into a distributed, replicated public database known as the blockchain, with consensus achieved by a proof-of-work system called mining. Satoshi Nakamoto, the designer of Bitcoin, claimed that the design and coding of Bitcoin began in 2007. In 2008, a white paper by Satoshi Nakamoto defined the Bitcoin protocol. The project was released in 2009 as open-source software. The network requires minimal structure to share transactions. An ad hoc decentralized network of volunteers is sufficient. Messages are broadcast on a best-effort basis, and nodes can leave and rejoin the network at will. Upon reconnection, a node downloads and verifies new blocks from other nodes to complete its local copy of the blockchain. The given figure shows the extended Bitcoin network showing various node types, gateways, and protocols. Here you can see how complex is networking in Bitcoin network. Bitcoin is structured as a peer-to-peer network architecture on top of the internet. The term peer-to-peer, or peer-to-peer, means that the computers that participate in the network are peers to each other, that they are all equal, that there are no special nodes, and that all nodes share the burden of providing network services. The network nodes interconnect in a mesh network with a flat topology. There is no server, no centralized service, and no hierarchy within the network. Nodes in a peer-to-peer network both provide and consume services at the same time, with reciprocity acting as the incentive for participation. Peer-to-peer networks are inherently resilient, decentralized, and open. The preeminent example of a peer-to-peer network architecture was the early Internet itself, where nodes on the IP network were equal. Today's Internet architecture is more hierarchical, but the Internet protocol still retains its flat topology essence. Beyond Bitcoin, the largest and most successful application of peer-to-peer technologies is file sharing, with Napster as the pioneer and BitTorrent as the most recent evolution of the architecture. Bitcoin's peer-to-peer network architecture is much more than a topology choice. Bitcoin is a peer-to-peer digital cash system by design, and the network architecture is both a reflection and a foundation of that core characteristic. Decentralization of control is a core design principle, and that can only be achieved and maintained by a flat, decentralized peer-to-peer consensus network. The term Bitcoin network refers to the collection of nodes running the Bitcoin peer-to-peer protocol. In addition to the Bitcoin peer-to-peer protocol, there are other protocols such as Stratum, which are used for mining in lightweight or mobile wallets. These additional protocols are provided by gateway routing servers that access the Bitcoin network using the Bitcoin peer-to-peer protocol, and then extend that network to nodes running other protocols. For example, Stratum servers connect Stratum mining nodes via the Stratum protocol to the main Bitcoin network and bridge the Stratum protocol to the Bitcoin peer-to-peer protocol. We use the term extended Bitcoin network to refer to the overall network that includes the Bitcoin peer-to-peer protocol, pool mining protocols, the Stratum protocol, and any other related protocols connecting the components of the Bitcoin system. Wallet holders comprised of multiple devices, like desktops, laptops, tablets, and phones. Ergo, devices can connect-disconnect, because the network is dynamic. Also, wallets load and verify transactions, blocks, upon reconnect. A transfer of bitcoins from one Bitcoin user to another. Containing an embedded script, a Bitcoin transaction is generated in a digital wallet and transmitted to the Bitcoin network. It is validated by a Bitcoin node and added to the blockchain-based ledger by a miner. See Bitcoin script, Bitcoin wallet, and Bitcoin mining. An owner of Bitcoin is listed on the blockchain as the owner of the transaction. When an owner transfers bitcoins to other parties, the ownership is recorded as a transaction on the blockchain. Effectively, the owner signs it over. The new owner is now listed on the blockchain as the owner. The blockchain contains a complete record of all bitcoins and owners, also of all transactions. Individual bitcoins aren't recorded separately. It wouldn't be practical. Therefore, Bitcoin transactions can contain several bitcoins, or parts thereof. Transactions are combinations of inputs and outputs. Inputs is payments, could be a single large amounts or multiple small amounts. Outputs is change, if any, and payments. UTXOs, unspent transaction outputs. A person's spendable bitcoins are stored in data records known as unspent transaction outputs, UTXOs. A single UTXO can contain any amount, but unlike a bank account balance, which is a single amount, a user's Bitcoin balance is like having cash in different rooms throughout the house. The sum of all those bills is the cash on hand. In the case of Bitcoin, the sum of all UTXOs for a given user is that person's coin balance. The UTXO database resides in a full node. Either a wallet or a third-party service maintains a database of UTXOs identified by the user's private key. To spend Bitcoin means looking for available UTXOs and determining which denominations make up the required amount for the recipient. Like paper money, each UTXO is indivisible. Therefore, if one or more UTXOs are larger than the amount to be paid, change is made in the form of a new UTXO, the same as buying something for $6 with a $10 bill and getting $4 in change. Transactions have inputs and outputs. We can understand this in a detail like: inputs are UTXOs and outputs are the payment to the recipient and any change, which there often is. The difference between inputs and outputs is the fee, which miners collect for doing the work. See Bitcoin mining. If the sender gets back change, a new UTXO is created. Assuming a 20-cent fee in the previous example of $4 in change, a new UTXO for $3.80 would be created. The actual amounts are not in decimal numbers but in Bitcoin fractions known as satoshis. Known as the UTXO set or UTXO database, all the UTXOs on the blockchain represent the total number of Bitcoins in existence. The actual number constantly changes because UTXO inputs are removed and UTXO outputs are added. See Satoshi, Coinbase transaction and Bitcoin script. Locking and unlocking scripts. A Bitcoin transaction contains both locking and unlocking scripts. The locking script typically contains the Bitcoin address, whereas the unlocking script usually contains a digital signature created from the user's private key. The unlocking script is used to verify the transaction. See digital signature, Bitcoin node, Bitcoin and blockchain. There can be transaction fees.
Thank you for watching Bitcoin Network tutorial. We have tried to complete maximum areas of Bitcoin Network in this tutorial. The next tutorial we will be uploading soon is on Bitcoin mining. Thank you for watching.